Hey y'all, in today's video, we're going to go back to some content that we learned in the last unit and kind of expand upon it. We're going to be focused on how to find the pH, pOH, H plus concentration, and OH minus concentration of strong acids and strong bases. So let's go ahead and get started. But in order to do this, we need to know when we're looking at a strong acid or a strong base. And these are the 7 strong acids that you need to have memorized and the 8 strong bases that you need to have memorized. This type of problem only applies when we're looking at these 7 strong acids and these 8 strong bases. The most important thing to recall when it comes to the strong acids and strong bases is that they all fully dissociate. What that means is that for every one of my strong acids that I put in, I end up with 1 H plus and one of my anions. All right, unless it happens to be sulfuric acid, which is a diprotic strong acid, where I actually end up with 2 H pluses and one of my anions, sulfate. Bases are the same. They fully dissociate. So when I'm looking at a monohydroxic base, like sodium hydroxide, for example, I get 1 sodium ion and 1 hydroxide ion. But when I look at a dihydroxic strong base, say calcium hydroxide, what I end up with is 1 calcium ion and 2 hydroxide ions. You also want to understand the pH scale. On the pH scale, as the pH gets lower, the concentration of H plus or H3O plus gets greater. And each one difference on the pH scale is a factor of 10 on the concentration of H plus or H3O plus. So in other words, something with a pH of 3 compared to something with a pH of 2, the pH of 2 has 10 times the concentration of H plus as the thing that has a pH of 3. On the pH scale, 7 represents a neutral pH. However, 7 is only neutral when the pH is being measured of a solution at 25 Celsius. But right now, understand that most scenarios that we are going to be dealing with consider a solution that is 25 Celsius. When we look at the pH scale, when you're at a pH of 7, it's considered neutral because the concentrations of H plus and OH minus are equal. And if you remember back to the last video, we know that the concentration of H plus and the concentration of OH minus multiply together to give you 1 times 10 to the negative 14th. So this means that at our neutral pH of 7, the concentrations of both H plus and OH minus are 1 times 10 to the negative 7th. To find the pH, you take the negative log of the concentration of H plus. To find the pOH, you take the negative log of the concentration of OH minus. If we do a little bit of algebra with our log rules, what we will find is that the pH and the pOH therefore add together to give you 14. So we can use a couple of different equations to be able to convert between these 4 different variables. You're going to use these several equations to be able to do that. So H plus times OH minus at 25 Celsius equals 1 times 10 to the negative 14th. pH plus pOH equals 14. So these are the most important equations. Let's go ahead and do some practice problems so we can apply this. In this first practice problem, the concentration of a strong acid, hydrochloric acid, is 2.51 times 10 to the negative 6 moles per liter. Now remember, strong acid fully dissociates. That means that the concentration of H plus in the solution is also going to equal 2.51 times 10 to the negative 6 moles per liter. Okay, it's a monoprotic acid. The pH is equal to the negative log of the concentration of H plus. pH of this solution is 5.6. pH doesn't have any units, right? So I'm not even going to worry about that. So I'm just going to take that pH and subtract it from 14. So 14 minus my pH equals my pOH. Therefore, my pOH of this solution is 8.4. Because the pH of this 25-degree solution is less than 7, we know that this is an acidic solution. In the second practice problem, we are given the pH and we need to use it to find the concentrations of H plus and OH minus. The pH is 8.76. So if I'm going to use this to find the concentration of H plus, I'm going to set up the equation 8.76 is equal to the negative log of the H plus ion concentration. I need to undo the log. In order to do that, I'm going to say 10 to the negative 8.76 and 10 to the log of H plus. Okay, and this is going to undo that log. Once I do that, 10 to the negative 8.76 gives me 1.74 times 10 to the negative 9th. And 10 to the log of the concentration of H plus cancels out that log, and we end up with just the concentration of H plus. So the concentration of H plus is equal to 1.74 times 10 to the negative 9th. For the second part of this problem, I'm trying to find the concentration of OH minus. So I set up the equation concentration of H plus times concentration of OH minus is equal to 1 times 10 to the negative 14th. Divide both sides by the concentration of H plus that I just found, and I find that the concentration of hydroxide is 5.75 times 10 to the negative 6th. Here's a partially filled table. I want you to be able to fill this table in, given the information that you have been provided. So what I want you to do is take a few minutes, and I want you to fill in the remaining parts of this table, and then we'll talk about it after you're done. All right, so here's the filled in table. Let's talk about each one. When I'm given the pH and I need to find the concentration of H plus, I'm going to say 10 to the negative pH. Therefore, the concentration of H plus for a pH of 3 is 1 times 10 to the negative 3. The concentration of hydroxide and the pOH can be derived in a couple of ways, but in the end, the pOH is equal to 14 minus the pH, so the pOH is 11, and the concentration of hydroxide is 1 times 10 to the negative 11th. In the second row, I'm given the pOH. I'm given the pOH. I can use the pOH to find pH quickly. So if the pOH is 2, the pH is 12. Therefore, the concentration of hydroxide from the pOH is 1 times 10 to the negative 2nd, and the concentration of H plus would be 1 times 10 to the negative 12th. In the third row, I'm given the concentration of H plus. I can use that to find the pH. So the concentration of H plus is 1 times 10 to the negative 4th, so therefore the pH is 4. The pOH would be 10, and the concentration of the hydroxide is 1 times 10 to the negative 10th. And then in the final row, which is 1 times 10 to the negative 1, therefore the pOH is 1, therefore the pH is 13, and the concentration of the H plus is 1 times 10 to the negative 13. Today's video was written, directed, produced, and edited by Angie Wu. Thank you all for watching it. I hope you enjoyed it, and I'll see you in the next one.